Chapter 4, Section 6 deals with the fundamental theorem of algebra. Get it? Fun? See what I did there? It's been a long week. Okay, so the fundamental theorem of algebra says that the highest degree of the polynomial in our equation gives us the number of solutions we have, which I said this like at least 8 times before the last quiz, so we should all know this. So here, our highest degree is 1, so our number of solutions is 1. For the second one, our highest degree is 2, so our number of solutions for this polynomial is 2. Next one, our highest degree is 3, our number of solutions is 3. And then the third one, our highest degree, or the fourth one, our highest degree is 3, so our number of solutions is 3. Notice how in our last example we have 2 solutions that repeat. So even though we have -1 twice and they're the same thing, they still count as 2 separate solutions. So we still have -1, -1, and 1 as our 3 solutions. This page just repeats what we had on the last one. So if our function f of x is a polynomial degree of n, where n is greater than 0, then the equation f of x is equal to 0 has at least one solution in the set of complex numbers. So finding the zeros and finding the solutions are pretty much the same thing. So example 1, part A, how many solutions does the equation x cubed plus 3x squared plus 16x plus 48 is equal to 0 have? How many? 3. B, how many zeros does the function f of x is equal to x to the 4th power plus 6x cubed plus 12x squared plus 8x have? 4. So finding the zeros and finding the solutions are the same thing. And all we do is look at our highest degree, and that tells us how many we have. Example 2, we actually have to find all the zeros. How many zeros are we going to have here? 5. So our highest degree is 5. We have 5 terms here. How do we factor? P over Q. So we take the factors of the last and put them over the factors of our first. What are factors of -8? 1, 2, 4, and 8. What is going to go inside of the box? So these are all of our possible factors. Now we need to test them by synthetically dividing synthetically. What goes inside the box? 1, 0. Good job including that 0 because we're missing a term here, so we have to include that 0, x to the 4th. 1, -2, -12, and -8. What do you want to try first? Four. All right, let's do it. My iPad is not working. All right, 4. Drop down the 1, multiply, add, multiply, add, multiply. What's 17 times 4? 68. 66. Yeah, 4 is not going to work. Let's try 2. Multiply, add, multiply, add, multiply, add, multiply, add, multiply. It works. So 2 is one of our answers. What do we do next? Turn it into a polynomial. So what's our first x degree going to have? 4, because we started with x to the 5th, so this has to be x to the 4th plus 2x cubed plus 5x squared plus 8x plus 4. Can we factor this? We still have 5 terms. We can try, Casey says. P over Q again. So we still have 5 terms. It doesn't factor. So we need to do P over Q again. So what are our factors of 4 now? 1, 2, and 4. We need the plus or minus of all of these. What's going to go inside of our box? 1, 2, 5, 8, and 4. What do you want to try first?
2.
2. Drop down the 1. We have 2, 4, 8, 13. Nope, 2 doesn't work. What can we try next? -2. Multiply. Add, multiply, add, multiply, add, multiply. What's 4 plus 4? Doesn't work. Got so excited for nothing.
I did.
All right, what do we try next?
Yeah. Oh,
Yeah, I think we did too. -1. So let's multiply. So this would be -1, add, 1, multiply, add, multiply, add, multiply. Yay, it works. So -1 is also one of our answers. I'm going to write that with the other one up top, just so we have our list going. My iPad lets me. There we go. -1. What do we do next? Got to make this polynomial first. So we have x cubed plus x squared plus 4x plus 4. And we can factor by grouping. What can we take out of the first group? X squared. What are we left with? X plus 1. What can we take out of the second group? 4. What are we left with? X plus 1. So our inside of the parentheses are the same, so we can factor by grouping. So we take what's on the outsides, put them together, so x squared plus 4, and then the inside stays together. Now our goal is to find the solutions or find the zeros. So what should we do next?
Put them both equal to 0.
Awesome, set them both equal to 0. So x squared plus 4 is equal to 0. X plus 1 is equal to 0. For the first one, how do we solve? Subtract 4. X squared is equal to -4. What do we do next?
Square root both sides.
Square root. So we get x is equal to? What are you missing? Plus or minus 2i. So we take out the negative and it becomes an I, and then the square root of 4 is 2. And anytime you take the square root of both sides, you need that plus or minus. So this gives us 2 more solutions, which I'm going to write up top. All right, let's just do the other one, and then I'll write it up top. How do we solve the next one? Subtract -1 on both sides, so x is equal to what? -1. All right, so let's add our 3 solutions up to the top. So we had -1, positive 2i, and negative 2i. How many solutions do we have? 5. So we know we did it right. Got our 5 solutions. Any questions here? Yes.
Why is it -2i and I is negative?
Because it was plus or minus 2i. So like we have the positive 2i and the negative 2i. So that's what the plus or minus means.
Wouldn't it just, if it has an I in it, should it just not have an I?
Well, the I is the square root of -1. So we took out the negative to become an I, but we still have like that negative 2i there. Any other questions on this one? All right, let's go to the next. So here we have the graph of f and the real zeros are shown. Notice that the only the real zeros appear as x-intercepts. Also, the graph of f touches the x-axis at the repeated 0. So since our multiplicity was even, because we had 2 of them, it touches and turns at -1, and then it crosses at 2. So we cross the axis at 2 and touches and turns at -1. And then it only touches, our graph only touches the x-axis at the real zeros. So since we had a 2i and a -2i, those are imaginary, doesn't touch at those points. Any questions? All right. Next, number 1. How many solutions does the equation x to the 4th power plus 7x squared minus 144 is equal to 0 have? 4. Because our highest exponent is 4. How many zeros does the function f of x is equal to x cubed minus 5x squared minus 8x plus 48 have?
3.
3. Good job. Any questions on this? All right. Number 3. Find all the zeros of the polynomial. How do we find the zeros or factor here? Well, first, how many solutions are we going to have? 3. We need 3 answers. How do we factor? P over Q. So we can't factor by grouping, that wouldn't work, and we have 4 terms, so we have to use P over Q. What are factors of 12? 3, 4, 1, 12, 2, 6. And these are the plus or minus of all of them, so the positives and negatives. What are factors of the first one? 1. What are factors of 1? 1. So we put all of these over 1, which would just make them all the whole numbers, so we don't even need to write that. What is going to go inside of our box? 1, 7, 16, and 12. So just all of our coefficients up here. What do you want to try first? 2. Drop down the 1, multiply, add, multiply, doesn't work. What do you want to try next? -3. So multiply, add, multiply, add, multiply. Good job. It works. So one of our solutions is -3. What do we do next? Turn it into a polynomial. So what do we start with? X squared plus 4x plus 4. What should we do next? We can factor. So what are two factors of 4 that add to 4? 2 and 2. So what do we get here in our parentheses? X plus 2 and x plus 2. We need to set them both equal to 0. So x plus 2 is equal to 0. X plus 2 is equal to 0. How do we solve?
Minus 2.
Subtract 2 on both sides, so x is equal to negative 2. The other one's exactly the same. Subtract 2 on both sides, so x is equal to negative 2. So negative 2 and negative 2. Are we done? Yes, done with this one. One more example. Any questions here? So we knew we were going to have 3 answers to start. We got our 3 answers. We're good. Do we have multiplicity here? Yep, multiplicity at negative 2, because that negative 2 repeats. All right, last one. Yeah. Still have 13 minutes left. Should be enough time. How many solutions are we going to have here? 5. So we're looking for 5 answers. How do we factor? P over Q. What are our factors of 4? 1, 4, and 2. What's going to go inside the box? Okay, 1, negative 3, 5, negative 1, negative 6, and 4. Good job. So all of our coefficients up here go inside the box. What do you want to try first? 2. So we drop down the 1, multiply, add, multiply, add, multiply, add. Doesn't work. Yep, doesn't work. Let's try 1. Multiply, add, multiply, add, multiply, add, multiply, add, negative 4, multiply. Yay, 1 works. So add that to our list. So that's our first one. 1 down, 4 more to go. What do we do next? Turn it into a polynomial. So we have 1x to the 4th power minus 2x cubed plus 3x squared plus 2x minus 4. Can we factor this? Nope. So what do we do? P over Q again. So we need our factors of negative 4, which are? What?
1, 2, and 4.
1, 2, and 4. What's going to go inside of our box? One, negative 2, 3, 2, and negative 4. Well, what do we want to try first? What do you want to try? Let's try 2. So we need to drop down the 1, multiply, add, multiply, add, multiply. Doesn't work. Let's try positive 1. Multiply. Add. Multiply. Add. Multiply. Add. Multiply. Yay, it works. Whew. It's a lot of work. And I just did this in I period, so it's times 2 for me. Alright, 1's another one of our answers. What do we do next? Turn it into a polynomial. So we have, what do we start with? Yep. Since the one before was x to the 4th, now we start with x cubed minus 1x squared plus 2x plus 4. Can we factor this?
Can we group it?
If we group it, it doesn't work. We don't get the same thing on the inside. So what do we do if we can't factor by grouping? Same thing. P over Q. What are factors of 4? 1, 2, and 4. At least the numbers are small, so we don't have much to try. Okay, what do we put inside? 1, negative 1, 2, and 4. What do you want to try first?
I think 2 is
I don't think so. If it didn't work before, it's not going to work now.
okay, 1.
1. Drop down the 1, multiply, add, multiply, add. Doesn't work.
4.
Let's try 4. So multiply, add, multiply. Doesn't work.
How about negative 1?
Try negative 1. Multiply. Add, multiply. Yep, it works. Yay. So negative 1 is another one of our answers. Let's add it to the list. All right, 3 down, 2 more to go. Thank goodness. What do we do next? Turn it into polynomial. So we have x squared minus 2x plus 4. Do we have 2 factors of 4 that add to negative 2? No. So if we cannot factor it normally, what do we need to do? Nope.
You multiply it outside? Or,
Can we take anything out? Nope. If you can't get it to factor, you have to use the quadratic formula. So if we don't have 2 factors of 4 that adds to give us negative 2, we use the quadratic formula. What's the quadratic formula? Yeah. Negative b plus or minus the square root of b squared minus 4ac over 2a. Now I know it's been a long week, so I'm not going to make you do this, but our last 2 solutions are going to come from the quadratic formula. So once you plug in your a, which is 1, b is negative 2, and c is 4, plug all those in, you'll get 2 probably imaginary solutions, most likely imaginary. So that's the end of, what is this? Example 4. Any questions? Yeah, I just put a question mark because it's a mystery. I won't make you guys solve it for today. But if there's any in the homework that you get down to this and can't go any further, quadratic. Now you know.